Well, good evening. Hope your week is off to a good start.
Yes, I hope yours is too.
It is, thank you. So today we are just going to continue with the rest of chapter 2 from lesson 5 to 7. It's pretty short, so at the end I'll do a recap of chapters 1 and 2. Okay.
Okay.
And feel free at any point to stop me if you want me to elaborate on anything, or if you need an additional explanation, anything like that, okay? Lesson 5 is on fractions and decimal equivalencies. Basically, to change a fraction to a decimal, you simply need to divide the numerator by the denominator. To change a decimal number into a fraction, all you have to do is write out the number with the decimal point. So in other words, write out the number as a whole number, and then count the number of decimal places in the decimal value. Then the whole number becomes your numerator, and the number of places becomes your denominator. And then you would just go ahead and reduce the fraction to its lowest form. And this will actually help you avoid wasting time on calculations if you can quickly recognize fractions in their decimal equivalencies. And we'll talk about that more this evening. Fractions and decimals, you can think of them as two different ways to depict a part or a proportion of a whole. So even though fractions and decimals are written in different forms, conceptually they're equivalent because they can be used interchangeably to represent the same portion of a whole number. So for example, 1/2 or 1/2 is the fractional representation for half of a whole, and the decimal equivalent of 1/2 is 0.5. And you would see this if you apply the long division of the fraction, as we learned to do earlier in chapters 1 and in parts of chapter 2 as well. So in this example, we're being asked to change the fraction 3/8 to a decimal point. And since 3/8 simply means 3/8, all you would do is just enter 3 divided by 8 into your calculator, and you would get your answer 0.375. And so 3/8 has 3/8 is the fractional equivalent of the decimal number 0.375. You can also change a decimal to a fraction by first writing down the decimal number over the place value name of the last digit to the right of your decimal. So for example, in this case, we're being asked to change 0.35 to a fraction. So all you would need to do is start by writing down the decimal number over the place value name. So the place value name in this case is hundredths, since 5 is in the hundredths place, right? So write down the whole number 35, and as I just mentioned, 35 over its place value name, which in this case is the hundredths position. And then you can proceed with your reduction. We know that 5 goes into 35 7 times, and 5 goes into 100 20 times. And as we discussed last week? Yes. This is its lowest term. And so you can confidently say that you've changed 0.35 to its fractional equivalent, which is 7/20ths, or 7/20. So here's a helpful chart kind of showing you decimals and their fractional equivalencies. These are useful ones for you to memorize. So for example, the fractional equivalent of the decimal 0.1 is 1/10, and the equivalent of 0.5 is 1/2. These are just ones that you should keep in mind. So make sure that you take some time to learn these and memorize them, because it'll be useful for you. The book actually suggest memorizing them, and I agree with that suggestion. It'll be useful for you because these are common fractions and their decimal equivalencies that you'll see a lot. And then they become even more useful when you're working on percentages. So take some time to get to know these. In my version of the book, they start on page 647. I know that you may have a different page number, but just look out for this chart and take some time to memorize and get to know these fractions and their equivalents, their decimal equivalents. Oh, I don't think I mentioned that. So here you see 1/3 and 2/3. Their fractional equivalents are decimals that have a bar written over the last, or not the last place, but the place where the author decided to stop, because this bar essentially means that this number goes on for perpetuity, like it goes on forever. So you'll see the display in your calculator, 0.3333, for as many places as your calculator can hold, but in reality, they go on forever. And so the author will tell you, okay, I'm deciding to stop at the thousands place, but I'm putting a bar over the third three to indicate that this value goes on forever. If the author had decided to stop at the 10th place, you would see the bar over the 3 in the 10th place. So anytime you see the bar over the number in whatever position, just know that the author decided to stop that repetition there, but understand that it's a value that repeats into eternity. This test tip tells you to look at the answer choices before you begin working on a multiple choice problem, because knowing whether or not an answer is in its fractional or decimal form may affect how you approach the problem. So this is kind of opposite to the advice that I gave you in terms of working on word problems, because in that scenario, I was advising you to try not to look at the answer, because they've given you superfluous information and they're really trying to test your understanding of the question, right? So they'll give you extra information that you don't need. And sometimes if you look at the answer ahead of time, I find that you'll get distracted and you'll think, oh, I think that's the answer, because you included superfluous or information that you didn't need. So I was advising you to try to personalize the question, understand what the question is asking you, work through it, arrive at your own answer, and then try to gauge whether or not you're correct and check yourself. So this tip is telling you the opposite of that, which makes sense for these kinds of problems, because because fractions and decimals have equivalencies, you need to check whether or not the question wants you to provide your answer as a fraction or a decimal. And so if you're looking at, usually in that scenario, they're not likely to give you a mix of fractions and decimals in your answer choices. You'll either see a list of decimals or a list of fractions, and then you'll know, okay, I need to present my answer in decimal form, or I need to present my answer in fractional form. Does that make sense?
Yeah, it makes sense. I get it.
So, yeah, in some cases, it can be helpful. Essentially, what I'm trying to say is, in some cases, it can be helpful to look at the answer choice to know how your answer should be presented, but don't look at the answer to try to match or to try to figure out what the answer should be, if that makes sense. Like, try to work on the question yourself, and then look at the answers with the understanding that some of those choices are intentionally wrong, right? So you want to help yourself by working on the question on your own first and then looking at the answer. But in case of decimals or fractional equivalencies, look at the answer to see what form you should present your answer in. So you can use fractions and decimal equivalents to save time when you're solving math problems. In this example, you're being asked or you're being told that each dose of cough medicine contains 0.25 ounces of medication. And the question's asking you how many ounces of medication are in 48 doses. If you know that 0.2, if you know that the entire bottle has been, I guess, divided or has been portioned for you to take 0.25 ounces at a time. Okay, so to solve this problem, you would need to simply multiply 48 by 0.25. And as we saw earlier, the fractional equivalence of 0.25 is a quarter, or 1/4. So all you would need to do is multiply 48 by 1/4, and you can easily just cancel out 4 into 48 to its lowest term, which is 12, right? 4 goes into 4 once, 4 goes into 8 twice, and the lowest, or its reduced form, the reduced form of 48/4, I should say, is 12. Okay. So knowing fractional and decimal equivalencies can also help you interpret remainders when you're using a calculator. So, for example, Ray inspects machine assemblies, and he must inspect 12 assemblies during his 40-hour work week. On average, how many hours can he spend on each inspection? Okay, so basically all you would have to do in this case, we're given two numbers. We know the number of hours, we know the number of inspections. So all we have to do is multiply the number of hours, divide the number of hours by the number of inspections. So that's 40 divided by 12. You would see once you enter enter these inputs into your calculator, 40 divided by 12, and press enter. You'll see on the right side of the display 3.333 into perpetuity, right? And so since you already know that 0.333 with a dash on top of the place that the author chooses to stop is equivalent to 1/3, you would simply write your answer as 3 1/3 hours. Or if you're asked to change that 1/3 into minutes, we know that 60 minutes, there's 60 minutes in 1 hour. So you would just multiply 60 by 1/3, and you would get 3 hours and 20 minutes. Okay, but for this instance, it's simply 3 1/3 hours. Okay, but definitely pay attention to the final form that the question is asking you to put your answer in. Okay. There are practice exercises in my version of the book. They start on page 649. Time to understand that. And I'm really glad that you're taking the time to come to class, and because you need time to learn the information, trying to learn it overnight is not a good strategy, is not a good idea. So I'm glad that you're taking the time to come to class and giving yourself enough time to take in new information, but definitely along with coming to class, work on the problems as much as you can, okay? So there are a lot of key ideas that you should pay attention to with decimals and fractions. This particular portion or this particular lesson is on the number line as it relates to decimals and fractions. So if you remember from our first lesson, a number line is essentially a picture that helps you visualize where a number belongs, or the place of a number on the number line. And in this particular instance, when we're dealing with decimals and fractions, it helps you compare the sizes of numbers. Okay, so numbers on the left are usually smaller, or are always smaller than numbers on the right. And number lines can also be used to compare decimals. So they can be used to compare whole numbers. We've seen that in chapter 1. They can be used to compare fractions, and they can also be used to compare decimals. And fractions and mixed fractions can also be represented on the number line as well. So on the reasoning portion of the math exam, you may need to recognize or locate fractions, mixed fractions, or even decimals on the number line. So a number line essentially is a line that represents numbers in order from least to greatest. So as you move from the left along a number line, the numbers increase in value. And as you move to the right, excuse me, as you move from the left along the number line, the numbers decrease in value. And as you move from the right, the numbers increase in value. So moving from left 5, 4, 3, 2, 1, they're decreasing in value, right? And if we're moving to the right, 0, 1, 2, 3, 4, 5, increasing in value, okay? The arrows on the end indicate that the numbers continue forever in both directions. So if you imagine zooming in on a portion of that number line, it might look something like this. So they're asking you to zoom in on this portion of the number line, and we'll see smaller striations or smaller divisions between 0 and 1, right? Between 0 and 1, we see 0.25, 0.5, 0.75 or 3/4, and 1, okay? And so here, if you want to think in terms of equivalencies, 0.25, we would have 1/4. We are halfway to 1 here, right? 0.5. We're 3/4 of the way to 1 here, 0.75. And finally, we're at 1, okay? And on and on. So a number line can include decimals, whole numbers, as we've talked about. For example, the point that represents 0.75, which is greater than 0.5, and also less than 1 is right here, this darkened point right here, okay? As I explained earlier, a number line can also represent fractions and mixed fractions in increasing order. So this is a representation of the same number line that we just looked at. This is the decimal version of it, and this is its fractional equivalent. So from 0, we jump to 1/4 or 0.25, 1/2 or 0.5, 3/4 or 0.75, 1, and then 1 and 1/4 or 1 and 5, which we saw here, okay? 1.5, which here is represented as 1 and 1/2, and so on, okay? So on the mathematical reasoning portion of the test, you may be asked to recognize a fraction or a decimal on the number line, or they may ask you to place a dot on a line to represent a fraction or a decimal value. And I think it would help you to just, again, think of these in terms of dollars and cents. You know, if you're being asked to represent 3 3/4, for example, whole numbers to the right, okay? And then since we're thinking about these in terms of dollars and cents, here we have 1/4, right? Or 0.25, a quarter of a dollar, right? Here we have a $half or 2/4, right? 0.5. Here we have $0.75 is the best way to put that, but 3/4.
Like 75.
Yes, yeah, okay. And so then I think it then simplifies things a lot for you, because now you can visualize, for example, if you're asked to indicate on the number line, where is 3 3/4, right? Just count 3 spaces over to the right, okay? And then imagine your $0.25 until you get to 75 cents, okay? And so that's all this tip is telling you here. So John works 5 shifts per week, and his boss asks him to spend exactly half of his time this week working on a specific project. How many work shifts will John devote to that project? And they're asking you to circle the answer on the number line below. Right? So his boss has asked him to spend exactly half hour of his time this week working on a specific project. How many work shifts will John devote to that project? And they're asking you to circle the answer. So if you circle 2.5 shifts, then you're correct, because simply you would multiply 5, the number of work days, by 1/2. Okay. And that to determine that John spends 2.5 hours, oh, excuse me, 2.5 shifts on the project. Okay. Let's see. An easy way for you can count half shifts. You would do that 5 times to get to 2.5. Or you can view, you can take 5 and multiply it by 1/2. And as we showed, or as we saw in the last lesson, that would give you 5/2. And you know that 5 over, because you're basically multiplying across, right? Remember, 5/1, if you want to write 5 in its fractional form, it would be 5/1 times 1/2, right? And then you multiply across, so 5 times 1 is 5, and 1 times 2 is 2. And so that gives you 5/2. But that's an improper fraction, right? And so you want to simplify that. 2 goes into 5 twice, right? Because 2 times 2 is 4. And then you have 1 left over. And 2, when you're looking at your fraction, when you're multiplying across your fraction, 2 is your denominator, right? Or 1 times 2 is 2. So you would have 5/2 reduced to its lowest terms, 2 1/2. Okay, so you have 2 ways of approaching that. You can literally count half, draw a number line, divide it into half points, and count. He's working 5 days a week, so count 5 times. And you should stop at 2 whole numbers, because 1/2 plus 1/2 is 1. And then you would count to the next half, that would give you 1.5. Next half, 2. The next half, 2.5. And when you stop at 2.5, you've counted 5, right? Or you could multiply 5 by 1/2. And that would give you 5/2, which would reduce to 2 1/2. Okay. There's
Okay.
two
Yeah,
ways.
I understand.
Okay, good. 2 ways to approach the same problem. And again, more exercises. So take time to work on these. And if you have any questions, feel free to reach out. So there's several important calculator keys that are used to work on decimals. And this section essentially is just showing you how those keys function, right? So fractions and decimal operations are entered in the same way as whole number operations on your calculator. So on your TI-30 XS multi-view, you want to use the decimal key for decimals. And then there's actually a special fraction key, and it looks like this. And that's what you want to use for fractions, okay? And then to work with mixed fractions, there's a special mixed fraction key, and that you'll find it above, right above the fraction key, using, and you would use the second function to get to this, and I'll walk you through that. So this right here is the fraction key. It's not so clear to see, but basically the third row of key, the second keys in your third row, you should see the fraction key. And again, it looks like this. Okay, and N is just telling you this is your numerator should go here. D is telling you this is where your denominator should go. And then U, they've chosen to use U as a symbol for a whole number, okay? In case you have a mixed fraction, that's where your whole number would go. So let's say 3.5, this is where 3 would go in your calculator, 1 would go here, and 2 would go here. And you would use these cursor keys to help you to help you move around. So, oops, jumped one slide ahead. So to help you, once you've entered 3, for example, you would press the up button to get to N, and then you would enter 1, your numerator, and then press the down arrow to get to, so that you can enter 2 into your denominator, the space for your denominator. So here's your fraction key again, here are your cursor keys, and then this is the toggle key to change between fractional equivalencies, and I'll show you that in the next slide. This is the decimal point key, so when you're working with decimals, this is the decimal point. This is the representation, I should say, for toggling from a proper fraction to a mixed fraction, okay? So if, let's say, you're given a top-heavy fraction, oops, you're given a top-heavy fraction 5/2, okay? And you don't want to spend time figuring it out, so you put it in your calculator. This is where you would do that. And you would toggle between your top-heavy fraction. You press the second function to get the calculator to toggle and give you the mixed fractional representation of 5/2, which would be 2 1/2, right? And again, you would press the green second function key. So after you've entered your fraction, press the green second function key, and it would toggle over to the mixed number, or toggle or switch over to the mixed number. So this is essentially just showing you how to use your calculator to perform decimal operations, and you would use, or you would do so in the same way that you would calculate whole numbers, or you would add, multiply, subtract, whatever whole numbers, with the exception that you're including the decimal point in the number. So in this, for example, if you're asked to solve 3.89 plus 2.5, you would simply press 3, the number 3, and then the decimal point that I showed you earlier, which again is right here, right below the number 2, okay? And then you would follow with the rest of the numbers, your operation key, and once you're done putting in your values, press enter, and you'll get your answer. Same with subtraction. So 5.2 minus 0.78. Start by entering 5, your decimal point, 2, and then press your operation key, in this case minus, enter 0.78, press enter, and you would get your answer, which would display on the right hand side of your screen. So when you're putting in your input, or when you're putting in the numbers from your question, they would display on this side. Okay, just so that you can see what you're entering, make sure that you're putting in the right values. And then once you're done and you press enter, you'll see your answer displayed on this side, on the right hand side. So yeah, the same applies to the other operations, multiplication and division. Again, you just want to put in your value, make sure that you're entering in the decimal point if there is one in the question, because it makes a difference to your answer, as you already know. Put in your operation. In this case, it's multiplication. And here we're multiplying 0.9 by 15. Press enter, and you'll get your answer on the right hand side. Same with division. 1.7 divided by 2. You just simply enter 1, your decimal point, 7, press the division key, and you'll see it on your calculator. Looks just like that. Divided by 2, press enter, and your answer will display again on the right hand side of the calculator. Excuse me. So you can use several calculator functions to work on fractions, and on mixed fraction operations as well. So make sure that you spend some time just playing with your calculator and understanding how to use the different functions. So in this example, you're being asked to reduce 56 over 448. And let's say you've done that manually, but you want to check your answer with your calculator, right? So the first thing you want to do is clear your calculator, and then you're going to press the fraction button, okay? And again, in case you forget, or just keep it in mind, N is it looks like N, or not looks like, it's the button that shows N over D, N being your numerator, D being your denominator. So press that button to enter your fraction. So once you've pressed that button, you'll see your display starting to flash, right? So then you can use your, let's say you decide that you want to enter your numerator first, enter 56, where your cursor is blinking, and make sure that you're putting the number in the right position, right? Because you don't want to put 56 in the denominator. So look at where the cursor is blinking, and it usually starts in the numerator, but for some reason, if it's starting in the denominator, put in the number that's relevant to the denominator, right? But let's assume that your cursor is blinking in the numerator, enter 56, and then you want to press your down cursor key, or your down arrow, so that you can enter your denominator, which is 448. And then because this function recognizes that you're putting in a fraction, you don't need to enter an operation like division or multiplication, for example, right? All you would need to do is put in the numbers and press enter. And once you press enter, you'll have your fractional equivalent on the right-hand side, which is 1/8. And let's say that your test is telling you, once you found the fractional equivalent, once you've reduced your fraction to its lowest term, we need you now to to express 1/8 as a decimal, you simply press the toggle key, remember, and the decimal equivalent will appear. And the decimal equivalent of 1/8 is 0.125. So this is just giving you an opportunity to practice operations with mixed fractions using the second function key. So again, the second function key will get you from so this is your fraction key right here. When you press second function, it'll take you from your proper or top-heavy fraction, whatever is the case with your fraction here, to your mixed fraction key, which, as we saw earlier, is represented by U and then N/D, okay? In this example, you're being asked to use the second function key to toggle from to toggle mixed fractions, okay? So a plastic pipe is to be cut into pieces measuring 1 7/8 feet, or 1 feet and 7/8 of an inch. The original pipe was 20 feet and 5/8 of an inch long. How many pieces can be cut from the pipe? Okay, so in this case, we're simply dividing 20 and 5/8 by 1 7/8. And the fastest way to do that would be with your calculator. So you want to clear your calculator and then recognize that a mixed fraction, you would need to use the mixed fraction button, which requires you to press second function and then the fraction key, okay? And let me, so since there's no actual button for you to press to get to the mixed function, which is right above, I don't know if you can see, but above each key, each key has some writing right above it, right? So this is your fraction key, and right above that, you can see that, well, you can't see it because it's so tiny, but right above that is your mixed fraction. It's telling you that you can use the same key for mixed fractions, and all you would need to do is first press second function. So by second function, you're telling the calculator, don't use the first function, which is the fraction key, use the second function written above it, right? So you press second function and then you press the fraction key, and the calculator recognizes that you want to use the mixed fraction option, which is right above the fraction key, okay? So we're pressing the second function key, and then that will give you, your display will change from the fraction to the mixed fraction display. You would see the U and then N/D, right? And so you then proceed to enter your the numbers in your question. Start by entering the whole number, 20, and then press the right arrow. So once you've entered 20, press the right arrow so that your cursor can move to the fractional portion. Then you would press 5 or enter 5, then press the down arrow so that you can enter your numerator, which is 8, right? And now, since the difference with this operation is that you actually have to press the division key, because we're dividing 20 and 5/8 by 1 5/8. Remember in the previous example, when we just wanted to reduce a fraction to its lowest term, or we wanted to reduce a top-heavy fraction to a mixed fraction, all we had to do was enter 5. We pressed the fraction key, we put in 5, we put in our denominator, which is 2, and then we pressed enter. There was no need for any additional operation. And we got our answer. In this instance, you have to press the division key because you're dividing two different, you're dividing two mixed fractions. So you have to use the operational key. So once you've entered your first mixed fraction, which is 20 and 5/8, you want to press the division key, and then you follow the same procedure. Press the second function key again, and then press the fraction key. Okay, and then you want to enter 1, your whole number. Okay, and then the right arrow, press the right arrow, enter 7, your numerator, press the down arrow, enter 8, your denominator, and then press the right arrow to move out of the fraction so that you don't accidentally press another key. Okay. Once you've done that, press enter, and you would get your answer. 20 and 5/8 divided by 1 and 7/8 is 11. Okay. And it's once you get used to your calculator, it's pretty easy. These functions become pretty easy for you to use. Just spend time practicing how to move from second function to first, and understanding that if you're working with just an improper fraction and you're reducing it, you don't need an operation, okay? Because your calculator is programmed to automatically reduce it. But if you're dividing two fractions, like we did in this example, you do need that operation key before you enter your second mixed fraction. Press enter, then you'll get your answer. Okay. So lots of practice, lots of opportunity for you to practice those kinds of questions, those kinds of examples, starting on page 661 of your textbook. So that's essentially it for today's lecture, very short, under 50 minutes. So what I want to do is spend time reviewing chapter 1 and chapter 2, refresh the information that we've learned. And then, as you're working on I won't give a quiz, but I will consider if you do the practice problems in chapters 1 and chapter 2, because it's a lot of information that we're going through. And I certainly want to make sure that you guys are taking in the information in bite sizes or in sizable chunks that allows you to digest it without being overwhelmed by the information. So yeah, let's go over chapter 1. So if you remember, chapter 1 began with number sensing and problem solving. And we defined number sensing as simply the process of understanding and relating and connecting to numbers. So for example, when you're trying to put a set of numbers in order, you need to consider where each number is placed. And this is what's known as the place value of a number. So when you're ordering numbers, you want to always compare the same place value between numbers. And sometimes when you're comparing numbers using place values, you may need to decide which value among the group of numbers that you have is the largest. So when you're making your comparison, excuse me, if the values that appear to the right of your decimal point are the same, you can get a better understanding of the sizing value of each number that you're comparing relative to other numbers within the group by looking at the digits that appear after the decimal point. Okay, and this is what's known as rounding, and we discussed that at length in chapter 1. So when you're sensing numbers, and again, we discussed that sensing simply means that we're trying to understand or relate or connect with numbers. So when you're sensing numbers, when you use a decimal point, know that you can round numbers up or down, right, to help you determine how big a number is. And when you're comparing it to a group of other numbers as well, you can round up or down, especially if the numbers before the decimal point are exactly the same. So for example, if you have 300.56 and you have 300.58, which of those two is the biggest? Well, the numbers before the decimal point are exactly the same. So look at the numbers after the decimal point to get a better sense of which of those two is actually larger than the other based on the value of the numbers after the decimal point. Okay. So here, or this portion of chapter 1 focused on place value. So a place value is essentially the basis of our entire number system. And if you remember, I used the terms digits and grouped numbers to explain. So again, think of digits as individual numbers like 1, 2, and 3. And so when I reference group numbers, I mean that we're putting individual digits like 1, 2, and 3 together to form a grouped number like 123, for example. And again, of course, you can order those numbers around 231, 321. But the idea is to keep in mind that 1, 2, and 3 represent individual digits, and when we group them together to form a grouped number. Yeah, so that was essentially the point of that. Maybe I should go over. So in this particular example, 350, we see individual digits grouped 3, 5, and 0. And from these three digits placed together, the number 350 is formed. And if we're looking at 350 as a grouped number, the 5 here represents the tens place, or 5 tens. So 5, the digit 5 here is in the, can you hear me? I'm seeing messages about my internet connection.
No, it's probably my internet connection. It's going in and out, but I can hear you.
Okay, okay. So if we're looking at 350 as a grouped number, the 5 there represents the tens place, or 50. So 5 tens or 50 is the place value of the digit 5 here. And then we talked a lot about the number line and how place value relates to the number line. So again, let's revisit the number 350, but this time in terms of money, right? So when you have $350, the position of the 5 here means that you have 5 in the tens position, or you can think of it as having 5 $10 bills. If we add an extra 0 to the right of 350, now we have a little bit more money, and we've gone from $350 to $3,500. And if you notice what happens to the 5, it moves over one place to the left, right? So anytime a number is increasing, usually its place values are moving to the left. So as you can see, when a 0 is added to 350, the 5 moves from the tens place over to the hundreds place. And you can think of that again as having 5 $100 bills or $105 bills. So after adding a 0 to the right of 350, the place value of 5, I should say, jumps from the tens place to the hundreds place. So if you look inside the purple box, the illustration that we used here for the number line, you see that it's a great visual aid to help you just imagine and recognize the place of a particular value or a particular digit within a number. So inside the purple box, we see the number 1,479. So when you see this grouped number, your brain automatically tells you that each digit has its own place and that the combined placement of each digit determines the value of the entire number. So one has, in this case, one is king, or it has the greatest value because it's in the thousands position, right? And so, or it's in the thousands place on the number line. So again, as we discussed, even though 1 is lower in value than 4, and it's also lower in value than 7, and it's also lower in value than 9, because of its placement on the number line, all of a sudden 1 has the greatest value in this particular scenario. Then followed by 4, which is in the hundreds place, and then 7, which is in the tens place, and then 9, which is in the ones place. So we also discussed that this number 1479 would increase in value with each move to the left of the number line. So for example, if we were to move the 1 by 1 single place value over to the left into the 10,000s place, and in its former place we added a 0, all of a sudden we've gone from having 1,479 to 10,479. If we were to, sorry about that, if we were to put a 0 in its in 1's former place. Okay, so the point of that is just for you to keep in mind that the place value of a number on the number line is very important, as it determines the value of the grouped number in question. And then we discussed inequalities, or inequality symbols, I should say. So we mentioned less than as the first inequality that you should pay attention to, and it simply looks like the tip of an arrow that's pointing to the left. So it's wherever that tip is pointing to is what you should pay attention to, right? So if you see 2, right? Oop, keep happening. Okay, so if you see 2 on the left-hand side of this inequality symbol, and you see 5 on the right-hand side, this inequality symbol is basically telling you that 2, you want to start with wherever the inequality symbol is pointing. Okay, so it's pointing at 2, so it's telling you that 2 is less than 5. Okay, and if you saw less than or equal to, and this is very useful, or this becomes important when you're rounding, let's go with 5, okay? If you see 5 is less than or equal to 25, it means that you can include 5 in everything that's less than 25. So that would be 1, 2, 3, 4, and 5. This equal to means include 5 in your range of numbers that you're counting that's less than 25. Okay. If you saw 5 is less than 25, take it as face value. It's telling you consider the number 5 only. Okay. And that the number 5 is less than 25. But if you see less than or equal to, know that it involves a range of numbers. Okay. And that equal to sign, or that in the indication there equal to means that you should include whatever number is on the left side of the inequality. So 5 is less than or equal to 25 means include everything that's less than 25 up to the number 5. Okay. Greater than looks like an arrow pointing to the right. And it's just telling you that wherever the tip of that arrow is pointed, whatever is on the left-hand side is greater than whatever the tip of the arrow is pointing to. So let's say you had 8 here on the left-hand side, and then you see this inequality symbol greater than, and you see 2 on the other side where the tip is pointing, you know that that inequality is telling you that 8 is greater than 2. Okay. Greater than or equal to, you would see the tip of an arrow with a line underneath it. So again, in terms of what we're including conceptually, we're saying 8 is greater than or equal to the number 2, for example, but we're including 8 in the range of numbers that happen to pertain to the particular inequality. I think that with the examples that follow or in the rounding examples, it should become clearer. And then I included this equal sign with a line going through it. If you happen to see that, it just means that the two numbers on either side of that inequality are not equal to each other, or they're different, or they're not the same. So, for example, 5 does not equal 1. Okay. So let's say that you have more than one number and you need to put them in order. We talked about what you would need to do in order to think through the process. And I think it was usually said that correctly explained that, you saw that 98 has only 2 numbers in it. So that automatically let you know that 98 is the least number. And then since 342 and 317 both have 3 in the hundredths place, the next thing that you would look at is your tens place. 4 is greater than 1. So that automatically lets us know that 342 is the largest number, followed by 317, which has a 1 in the tens place, and then followed by 98. So in terms of ordering numbers, you want to start from left and compare the value of the first digit, and then move to the right accordingly and evaluate the place number or the place value of each digit, and then compare them. Whichever one is bigger, obviously, is the larger number. And so, yeah, essentially the slide is just discussing what we just talked about. We started from the start by comparing each digit. It's automatically our smallest. And then you move from left to right, comparing the place values until you have ordered your numbers in the correct or in the required order. In this case, it's from least to greatest, so 98, 317, and 348. The 342, sorry. Here is where our inequalities become important. We talked about trying to round 2,400. Let me see what the, okay, so there's nothing that came before that, okay. So yeah, we're basically trying to locate we're trying to round 2,451. So you would locate, since there's no number in this group that's greater than 2,000, you would locate the next place value, which is 400. And this is the number that you would need to round either up or down, depending on the value of the digit to the right. So in this case, 5, the rounding rules are that if the number to the right of the digit that you need to round is greater than or equal to 5, you want to round up, right? And if the value of the number to the right of the digit that you want to round is less than 5, don't change the number. So in this case, we're trying to round 4. The value to the right of that is 5. And 5 equals 5, right? Because in our conceptual definition there, the number needs to be greater than or equal to 5. And 5 equals 5, right? So like I mentioned earlier, you want to include, when you see that line underneath your inequality, meaning equal to, you want to include the number that's being referenced. And in this case, it's 5, right? And so 5 is equal to 5. So we're going to round up this number. And the example I gave was, let's say, Jaleesa, your boss wants you to take a field trip to, I don't know, Connecticut. And you need, but it's a one-way field trip, and he's gonna buy you a plane ticket back, okay? So you don't have to worry about getting back. But you need to buy gas one way, and he tells you to use Google Maps to figure out the distance, and then find out the price of gas and multiply the distance by the price of gas. And you've done that, and you found out that you're gonna need around $2,451 one way, right? But you don't want to ask your boss for exactly $2,451 because your boss thinks that you're this budget guru, okay, and that you don't waste money. And but you also figure that on your way to Connecticut, you might encounter traffic, and sitting in traffic burns gas, right? So you don't want to ask for exactly $2,451, but you want to ask for a number in that ballpark that's going to keep you looking like the wonderful budget expert that you are, Jaleesa, but that is also going to get you to Connecticut. So you tell your boss, I need around $2,500 to get to Connecticut. And your boss asks you, well, how did you arrive at that answer? Well, you tell your boss, I didn't want you to give you the exact number because, I might actually need more gas in case I have to sit in traffic. So I'm giving you a rough estimate of 2,500. And what you did was you looked at the hundreds place, since there's no number greater than 2,000. You looked at the hundreds place, and in the hundreds place was 4. Then you looked at the number to the right of the hundreds place, which is 5 in the tens position. Okay. Since 5 is included in our instructions, if the number to the right of the number that you're trying to round up is 5 or greater, you would round up. And if the number is less than 5, don't change the number. And so you looked at 4 in your hundreds place, you looked over to the right of your hundreds place and you saw 5, and 5 is included in that inequality of greater than or equal to 5. So you rounded up the amount that you needed, and you're telling your boss budget estimation of the amount of money that you need, which is 2,500. Okay, and your boss not going to be able to argue with you, Jaleesa, okay? Because it's a mathematically accurate estimate. So one tip that this chapter gives you is checking your answers by rounding them, because sometimes you might get an answer that's a little bit off from the list of answers in your multiple choice. And you'll find that if you go back to your steps and you round your numbers a little bit, you then might become closer, or you might actually find the right answer or the exact answer in the list of in your multiple choice list. So sometimes as well, if you're off, like let's say you've done your calculations and your answer is 3.51 and you see 3.50 in your list of numbers, but then you're also, your other options are like 50.2, 39.3, and 40.1, for example, then you know that, okay, you're off by one decimal place. So you can go ahead and select 3.50, even though your calculator is showing 3.5 approximately within the same range. Okay, and that's essentially what this is telling you, that you can use approximations, just kind of gauge, okay, am I in the same ballpark or as the answer that's shown, even though I'm off, my calculation is off by a couple of decimal points. So off to lesson 2 of chapter 1, which was on whole number operations. And the key idea to note here is that when you're combining amounts that involve addition and subtraction, the goal is to understand what the operation is asking you. So if the question is asking you to combine numbers, then you know that operationally you're being asked to add. If the if the question is asking you to find the difference between numbers, then you know that operationally you're being asked to subtract. And sometimes when you see and, that can be an indication of multiplication, but read the question carefully, okay? Yeah, and then division will, I don't want to say it will be clear, but I think that when there are lots of word problem examples, and when you're working through them, try to have a note on the side of keywords and the operation that is required. Because a lot of the times, as I discussed before, I believe, the question is not going to tell you automatically add 6 plus 8 plus 9, right? It'll use certain keywords that will tell you the kind of operation that you need to use, right? But if you're not used to those keywords, you're going to get stuck with the problem. You're not going to know. So you don't want to get stuck. And you won't get stuck if you practice working on the word problems and pay attention to the language that they use, the keywords that they use when they're asking you for specific operations. And then write those down or try to memorize those, so that when you're on the test, you'll know exactly what operation a word problem is asking you to use based on the type of wording in the problem. Okay, and the problem will always give you, it'll always give you hints. Okay, it'll always use, because mathematically, if a problem is telling you to combine, so the problem will always give you the correct wording. It's just up to you to translate that into the correct mathematical operation. Okay, and it will help you when you're doing your word problems to pay attention to what keywords are being used for what specific operations. And I think there's even a table that talks about that. So when you use addition, you need to combine amounts, and the answer in an addition problem is called the sum or the total. So if a word problem is asking you, find the sum, combine, those are keywords that you should write down and know that, okay, when I see these two keywords in a word problem, I know that they're asking me to add whatever values are relevant to the problem. Okay. So when you're adding, it's helpful to stack your numbers in a column and then be sure to line up the place value columns and then work from right. So on this my right, right, okay. I know it's probably looking like I'm pointing to the left on your side there, but you want to start by working from right to left, starting with your ones column and then proceeding accordingly. And then sometimes the digits in a place value column, if they add up to 10 or more, you want to regroup when that happens. And we saw examples of that, and we'll go over that. Okay, so you want me to skip this or?
Yeah, you can skip the addition and the
Okay, yeah, it's pretty
subtractions.
basic,
I
right?
get that.
Okay, okay, cool. Um, let's see, all of this is adding and subtraction. Oh, now we're in multiplication, I think. Let's see. Yes. When your multiplication sometimes can essentially translates to you adding the same number multiple times. So in this instance, instead of adding 24 plus 24 plus 24, you would just multiply 24 times 3, right? Which would give you, what's this, 8, 12, 78. Right, 73, 12, 72, sorry. If a problem asks you to find the product of two or more numbers, you know that you're being asked to multiply. So here we are being asked to multiply or find the product of 24 and 63. So again, you would stack your numbers vertically and make sure that you align the correct place values. And then proceed with your multiplication. So 3 times 4, 12. You write down 2 and you regroup the 1. Okay. 3 times 2 is 6, plus 1 is 7. So that should give you 72. 24 times 3, 72. And then you want to move over to your tens place. You're done with your ones. You're going to write a 0 under the 2, right? Remember to just kind of let us know that we're done with the ones, and also just as a placeholder so that you don't put your next answer in the wrong place. So you write a 0 under the 2, and then 6 times 4 is 24. So you're going to write down 4 here, and you're going to carry the 2. 6 times 2 is 12. plus the 2 that you carried over, 14. So your answer here would be 1440. Okay. So then you would add 72 to 1440, get your 1512. So let me go over this. 3 times 4 is 12. You write down 2 and carry the 1. 3 times 2 is 6, plus 1 is 7. So we're done with our ones place multiplication of the first number. Our answer is 72. We're going to write down 0 to make sure that we don't put our next answer in the wrong place. And also just to remind us that we're done with our ones place multiplication. We move over to 6. 6 times 4 is 24. You write down 4 and carry your 2. 6 times 2 is 12, plus the 2 that you carried over is 14. 2 plus 12, right? 6 times 2 is 12, plus the 2 that you carried over, 14. So we would have 1440 here, right? And then you just proceed to add 72 plus 1440, gives you 1512. Okay. So when you're dividing, you're essentially finding how many equal parts of an amount can be divided, how many equal parts one whole amount can be divided into. And the amount that's divided is called the dividend, okay? And the number that you're dividing by is called the divisor. And your answer to the division problem is called the quotient. So here, the example that we're given is that at a garage sale, 3 children sold their toys for a total of $54. And if they share the money equally, how much money should each child receive? So essentially, we're dividing 54 3 ways so that each child can receive an equal amount of the money that they made. Right? We're dividing 3 into 54. We know that 3 goes into 5 one time. 3 times 1 is 3. So you subtract 5 from 3, and we're left with 2. But we're not done. We're going to bring down the 4. Okay. And now we have 24 left over in our partial division that we still need to divide. Okay. So 3 goes into 24 8 times. 3 times 8 is 24. 24 minus 24 is 0. We have 0 remainders in our partial division, so our answer is 18. Because 3 goes into 54 18 times, each child should receive exactly $18. Okay, here we're asked to divide 1006 by 4. Again, your divisor goes outside of the division symbol here. Dividend goes inside. 4 does not go into 1, so we move over to the hundreds place. And again, this is I guess one of those rules that you want to write down, because usually when you're subtracting, when you're multiplying, when you're adding, you work from right to left. Okay, it's only with division that you work from left to right. So starting on the left in the thousands position, 4 does not go into 1, so we move over to the hundreds position, right? So 4 into 10 twice, okay. 4 times 2 is 8. Write down 8. Draw your line. Okay, 10 minus 8 is 2. But we're not done. We're going to bring down the 0. 4 goes into 20 5 times. 4 times 5 is 20. 20 minus 20 is 0. Write down your 0. Bring down the 6. 4 goes into 6 1 time. 4 times 1 is 4. Subtract 4 from 6, and your remainder is 2. And so your answer is 251 with the remainder of 2. Yeah, so here's a tip on multiplication tables. Just kind of suggesting that you should take time to memorize multiplication tables so that as you're going through those calculations, you're not wasting time trying to figure out things that you could otherwise have figured out had you memorized the multiplication table, basically. So this section was on calculator skills. Just use your calculator if you think that it's going to save you time. But you definitely want to learn the placement of the keys and how to perform specific functions so that you don't waste time using your calculator. So the calculator can save you time if you know how to use it. If you're trying to figure out how to use it, that can actually be a time waster. So make sure that you have enough practice with your calculator and know how to use it. And
I still have to get one. I don't have one yet.
oh, you don't have
One
one?
of those calculators.
Okay.
No, not yet.
Okay. I wonder if you can borrow one from your local library.
I don't know. I'll just go to Walmart tomorrow
Okay.
and
Okay.
grab one.
Yeah, okay. And then spend time. And then if you need, there are lots of YouTube videos that you can watch as well that,
Okay.
while you're using it, if you get confused about a function, you can watch some YouTube videos
Yeah.
that'll walk you through. Yeah. Okay, so um, just as a reminder, you'll have access to the online version on your test. And this is just telling you that if you're going to use the online version, it's going to appear as an icon on the top of your computer screen, and then just move it so that it's out of the way and doesn't cover your problem. But yeah, I support you getting one, a handheld one, so that you have better control of it. And you can get used to practicing with it as well, because um, I wasn't able to find a version available online, so it'll be difficult trying to get used to the version provided during the test, as you're working on solving the test problems. I think it's better to just get a handheld one like you're planning on doing. And then this is just going over basic operations. You should know that your calculations, as you're working on them, they will appear on the left-hand side. And then your solutions will always be on the side. These are your arrows to help you navigate. So when you're working on functions, for example, or let's say you're typing and you see that one of your calculations, you've accidentally entered the wrong number, you can just press the arrow key and then press the delete key, not clear, because clear will clear out everything. Okay, you can just use the left arrow key to get to whatever number you entered incorrectly. Press delete, put in the right number, and press the right arrow to get to the end of your entry. And then keep working if you need to add additional entries, or press enter to get your solution. These are your operation keys. So division, multiplication, subtraction, addition will all be on this side right here. And then your digit keys to enter your numerical values. You turn on the calculator here. And then the second function key is right here, the second function key that we were talking about. So this is the fraction key. And if you wanted to use the mixed fraction key, you would press the second function and then the fraction key, and it would bring up the mixed fraction operation, which you would see on this side. And then you would just toggle between the empty values, if you will, using these keys right here. Yeah, this is just telling you that your calculator is available online or office supply stores. Walmart probably has as well. So just some more tips on how to use your calculator. You always want to start by clearing the calculator because sometimes with those TI calculators are they're programmable. So I know in the past I've used the 82, the 89, and the 93. And sometimes what happens with TI calculators is, let's say you are doing some practice questions and you turn it off, right? It'll store whatever you were working on in its memory so that when you turn it on, you can, let's say you were working on a long string of numbers for whatever reason. It'll remember where you were, right? So that's why the book always advises you to clear, and it's very good advice, to clear your calculator. It doesn't matter if you just turned it on. Always clear your calculator because these calculators are they store information from your previous calculations in their memory, and if you don't clear the memory, you might be including information from a calculation that doesn't apply to what you're working on, and then your answer wouldn't be correct. And that's happened to me quite a few times, and trying to figure out, wait, what am I doing wrong? Only for me to find later on that I forgot to clear the memory. Okay, so to always clear the memory of your calculator and then proceed with your calculations. And you know how to enter values, so I won't bore you with this portion.
Okay.
Okay, so now we're on to word problems. And then the key to kind of pay attention to in this section is that there's word problems. You'll always, they're almost like it's almost like putting pieces of a puzzle together, and as long as you follow the order that's being suggested here, 9 times out of 10 you'll get the right answer. And I say 9 because sometimes if you include the information that you don't need, it might lead you to the wrong answer. So that 1 out of 10 is that time that you may accidentally include information that you don't need. But if you're including information that you need or that you're supposed to use, and you're following the steps, you should almost always arrive at the right answer. So you want to read very carefully the question, and I would read the question once just to get it in your mind, and then I would reread, because sometimes I find that when you revisit a question, clarity comes the second time around. Okay, reread it the second, third time if you have to. Make sure that you understand what the question is asking you, and if you're finding that you're struggling with understanding it, try to personalize it. Okay, replace names with people that you know. Make the numbers accessible. Think of them in terms of money or the number of times that you, I don't know, drive to Walmart a week or whatever, like whatever you need to do to make the question more accessible to you. Because I find that with word problems, sometimes when you just personalize them, when you or you think about them in everyday activities, it's a whole lot easier to understand. Okay. So like with the scenario where we were dealing with Sally and her couch, I don't know if you remember, she needed material. It might have helped to think of it in terms of you, okay, let's say Jaleesa is trying to redecorate her living room, and she decided that she no longer likes the fabric on her couch, right? Like if you're thinking about it in that terms, right? Okay, I'm redecorating my living room. I no longer like the fabric on my couch. You know, how much am I will 4 yards? And then it might help you to try to translate yards into, so if you're, when you're working on these word problems and you see measurements that you're not familiar with, try to translate it into ones that you are familiar with, because it would make it easier to translate or to understand the question. So let's say if you had translated that question, it yards into its equivalent in inches, for example, it would have been more accessible to you, because then you would know that, well, try to, if you see you know, in terms of measurements, like write down the uh, write down measurements that you see that you're not familiar with in terms of measurements that you are familiar with, right? So that way, when you're working on, like for example, if you see one foot, but you're more comfortable with inches, you know that there are 12 inches in 1 foot, right? So you can have a little note card and write down the equivalent, so that if you see a question asking you, you need, will 5 feet of material cover, I don't know, 6 couches, right? Well, maybe if it's hard for you to imagine 5 feet, you can translate 5 feet into its inches equivalent. 5 times 12 is 60. So would 60 inches be enough to cover 5 couches? No, right? If you're familiar with measurements, I don't know. I'm just trying to um, uh, open your eyes to different ways of conceptualizing a word problem and making it accessible to you, so that you can um, approach it in a way that's easier for you to understand, right? So you want to read the information carefully, make sure that you understand what the question is asking you. And then when you've worked on your problem and you found the answer, check the answer to make sure that it makes sense to the problem, right? For example, if the word problem has a 5 in it and has a 4 in it, and maybe has a 3 in it, you know that at most 5 times 4 is 20, times 3 is 60. You know that at most your answer shouldn't be 180, right? Like your answer should be in the range of the numbers in the problem, for example, right? So that's what this tip is telling you here. Just make sure that your answer makes sense. Like obviously you are now aware that that 3 might be a number that you don't need, right? So maybe your answer is actually just really 25 times 4, right? But you know that 20 is still within the range of 60, which is the maximum number there if you were to multiply all those numbers, and you don't want to be putting down an answer that's like 8,005, for example, right? So check that your answer makes sense with respect to the information that you've been given in the problem. So here are the steps that the book suggests that you follow And I would suggest writing down these steps. And then when you're working on each word problem, like let's say you've read through the question, write down the keywords from each step, and then under each step, do what's required. Okay. So step one is asking you, what is the question? What is the question asking me to find? So do what's required. Like, make sure that you understand what's being asked. If you need to translate it and, make it accessible, put your name in it, put use money if that helps you, use activities that you do every day, stuff that makes the question easy for you to understand. Okay. And then step two, what information from the problem do I need? Because again, sometimes the problem might include extra numbers or extra information that you don't need. Not necessarily, I wouldn't say that they're trying to trick you, but they're trying to reinforce your understanding of the question. They're trying to gauge, well, how well are you understanding um, how well are you understanding the material based on the information that you're being provided, right? So you want to make sure that you're not using information that you don't need. So like read through the question again carefully. Is there information in there that I don't need to answer this question? Okay. Once you've made that determination, now you need to decide what operation am I being asked to use. So does the word problem mention combining? Because if it does, then you're adding. Does it mention finding the difference? Because if it does, then you're subtracting. Does it use the word and, right? Because sometimes that can mean multiplication, okay? Or is it asking you straight away to divide? Is it asking you to find the quotient, right? Because that means division, okay? Is the question asking you to find the product? That means multiplication, okay? So for this step, I would advise that you write down keywords that are associated with certain operations. And again, operations are those four main um, mathematical procedures that we have covered: multiplication, division, subtraction, and addition, right? So I would, if I were you, make yourself a little table and put the addition operation, and then next to it, use all the keywords that pop up in word problems that require addition, right? Combination, sum, total, right? And then do the same with division, quotient. If you see the word dividend, divisor, numerator, denominator, right? You know that you're dealing with division, on and on, okay? And then step four, what is your solution? Proceed based on based on the information, based on your understanding, the information provided that you need, and then the correct operational procedure. What is your solution, right? Find the solution, which is step four. And then you always want to check your answer, right? Does your answer make sense in terms of what the problem is asking? Does your answer make sense in terms of the values that are in the problem, right? Because like I said earlier, you're not trying to put down 8,400 when your problem only mentions 52 and 4 or whatever. You know what I mean? Like, gauge your answer in relation to the values that are provided in the question. Okay, and so here's a good start. Like, you can use this chart to help you with your little memory card that you're making, right? With addition, you're combining amounts in different sizes. finding the sum, you know, write down the kinds of keywords that are associated with addition. And then start, this is a good start for subtraction, find the difference. Multiply, combine the same amount, but multiple times, okay? Don't get stuck on combine, because here we see combined amounts of different sizes. Okay, they're different sizes. But here, they're the same, right? So it's easy to multiply. It would be like if you had five $10 bills, right? You can combine by adding 10 plus 10 plus 10 plus 10, and that would, or 10 plus 10, however, 10 plus 10 5 times. Okay, and that gives you 50. Or you can just simply say 10 times 5, because we have 10 5 times, right? So operationally, there's a similarity there between addition and multiplication, but you need to know that in some cases where it's different sizes, like with our example with 10, right? The size, the value 10 is the same 5 different times, right? But if you had a 10 and a 5 and a $2 bill and a $1 bill, you're not going to multiply, right? You're going to add them because you're combining different sizes. But if you had just five $10 bills, you can multiply because you got $10 bills 5 times, so 5 times 10, or you can add them 5 different times, right? So pay attention to that. Like if the amounts are different, definitely don't multiply. You want to add. If the amounts are the same, you can multiply. Okay. So with combinations, pay attention to the type of combination in question. Is it values or numbers that are different from each other, or are they the same, which would require multiplication? Okay. So yeah, we talked about subtraction, right? And then with division, you're separating one amount or a whole pie, that if you think about those circles that we discussed last time, into equal sized groups, okay? And then it helps a lot when you're thinking of division in terms of partitioning, or in terms of separating a whole into its small into smaller pieces within that whole. Yeah, we talked about this already. Of the mathematical reasoning questions are going to include information that you don't need to answer a specific question. And they'll even have matching answers in the in the multiple choice. So just make sure, don't get tricked. You know, make sure that you're reading the question, understanding what it's asking you, and then asking yourself, is this information that I need? You know, and if it's not clear, try to use an example that's easy for you to understand. Okay. Um, don't change the wording, okay? Because if you it can affect how you approach the question, okay? Just maybe if you're reading something that's and you're struggling with accessing it, change the name only, right? But like if it tells you Sally goes to the store 12 times a week, okay? It might be easier for you if you think about it as Jaleesa goes to Walmart 12 times a week, and you know that there's 7 days in a week, right? But don't change the question to Jaleesa goes to the store twice a day, 12 times a week, because now you're answering a completely different question. And so the point I'm trying to make is when you're changing the question to make it more accessible, make sure that it's actually it's still matching it still looks like the original statement, okay? Like all you're changing is maybe your name and the name of the store, right? But don't change the order of operations, don't change the number of times you go to the store, that kind of thing, okay? I mean, I'm sure that's that's pretty obvious, but just want to throw that out there. Because sometimes when you're trying to understand a question, you could digest it or dilute it so much that it completely changes the meaning of the question, and then you're answering something completely different. Okay, and I'm saying that because I've done that. So, all right. So to cover a sofa, we've went over this already. Sophia needs 12 yards of fabric that costs $14 per yard. How many yards does Sophia need for three sofas, right? And if you remember, we simply just multiplied the number of yards that she needs by the number of sofas, because the cost um, is not really necessary. I mean, it will be when she gets to the register, right? But for now, the question is just asking you how many yards does Sophia need? And all we would need to do to find that information is multiply 12 by 3, which is 36, okay? And then here's another scenario where you want to check your answers in relation to the question, because if you're getting an answer like 900, I mean, like that's not in the range of any of these numbers. If you decide to multiply all three numbers together, right, 900 is not in the range. So you want to make sure that you're answering the question using information that you need. You don't need 14, but that your answer is also within a reasonable range of the numbers in the question.
Yeah, no, I get
Okay, good.
it.
Um, okay, and then in this, there are some word problems that require you to perform multiple steps, and this is one such example. So when you're working on multiple step problems, there are two things to keep in mind. Again, you want to ask what is the question asking you to find? And then did you answer the question completely? Okay. Did you answer the question? So in this example, to win a prize, Sarah's daughter has to sell 75 boxes of cookies in 3 days, right? If she sold 16 boxes on day one and 34 boxes on day two, how many boxes would she need to sell on day three? Well, if you start by figuring out how many boxes she sold on day one, which would be 16 times one, okay, then you write down 16. So we know that so far she sold 16 boxes. And then you continue to day two, 34 times two, which is 68. So we know that 16 plus 68 is 34 times 2, 68. Yes, it is. Okay. 16 plus 68. That's odd. Oh, 30. Do you see what I just did there? She sold 34 boxes on day two. I multiplied 34 by 2. Was I supposed to do that? No. She sold 34 boxes. The day here doesn't count. Okay. But when I added it together, I was like, that's odd, because the the sum that I got is greater than 75, right? So use me as an example. That was a perfect example of this tip here. Did I answer the question correctly? I didn't. And I realized that right away, because the sum that I got I was like, that's a little bit like,
No, I get, yeah,
yeah,
it'll get you caught up.
yeah. So now I've gone back and realized, oh, 34 boxes on day two literally means she sold 34 boxes. The two is not factored in here, right? So far she sold 34 boxes and 16 on day one, okay? So, oops. So 34 plus 16 is 50. And then again, you need to ask yourself, did you answer the question completely? No, because she needs to sell 75 boxes, and so far we figured that she's only sold 50, right? So there's 25 boxes left. And that's exactly what the question is asking you. How many boxes would she need to sell on day 3 to win the prize? And the answer is 25, because she sold 16 on the first day, 34 on the second. So you would add 16 to 34. And then you would subtract your answer, which is 50, from 75. Okay. It would be easier to say, okay, day 1, number of boxes sold, 16. Day 2, so if you had written down day 2 and you write down the number of boxes, 34, you would automatically see in your head that you need to add, right? Because you've stacked your columns 16 plus 34. So you would have seen that right away if you wrote it down. So that's another tip I would suggest, like write down write down the information that you're being given. Okay. Okay, it's the same. All right. Here's just letting you know that there are different ways to indicate multiplication. So n times r, or you can see, if you see n and r written together, you know that that's an indication of multiplication. This is a functional notation. So it's telling you that n is also a way to indicate multiplication. This looks a lot like the dot product. So, and usually the dot is a lot higher, but this is also a way of indicating multiplication. So far, I haven't seen any examples of this in the book, but maybe we'll get there later on. So yeah, this is just showing you ways to indicate the division. You can write C and use the division symbol followed by N. That tells you C is being divided by N. Or you can write it in its fraction, or as its fractional equivalent, C over N. Okay. This is just telling you that you can rewrite a formula in terms of the variable that you're interested in solving. So here in this case, C equals N times R is our formula. Our variables are C, N, and R. And if you remember, we said that a variable is simply a notation for a number that varies. We don't know what that number is yet, so we'll just put in representative letters that represent the respective values. So for example, when we were looking at the calculator function, right, the calculator doesn't know what fraction you're trying to find, but it's used a variable notation to let you know that at any time, if you have a numerator and you have a denominator, it can help you find the solution. So it's used N as to represent your numerator, like whatever numerator you need, and then it uses D to represent your denominator, right? And that's essentially what a function means. Is you can think of it as a formula that has variable notation, and the variables are just place numbers for whatever number you decide to use that formula to calculate. Okay, so again, back to your calculator. we see the functional notation for a fraction as n over d. Essentially, you know, it's just your calculator is just simply telling you, I don't know what they're going to ask you on the question on the test. You know, I don't know what they're going to ask you to input here, but whatever number it is, you know, and you might get more than one question asking you to input fractions. Whatever number it is, the formula is always the same, n over d, right? And so that's essentially what a function means. A function is a formula that's always stays the same and has the same and also it stays the same in terms of its operational consistency. In other words, you know, if we're trying to divide two numbers, the numerator is always going to go on the top, okay, and we'll represent the numerator by n, and the denominator is always going to go on the bottom, and we'll represent the denominator by d, right? And so n or d are called variables. Why? Because they vary, like depending on what problem you're working on, right? N could be 5 today, but then tomorrow it could be 500, right? So since we don't know today what the numerator is going to be, we're just going to represent it as n, right? And then same with your denominator. D could be 50 today and 4,000 tomorrow. And since we don't know, we're just going to use D as a placeholder. So when you see that terminology, don't get nervous, okay? They're just ways. A formula is simply an operation that's standardized, it never changes, and the variables are the numbers that you enter into that standardized formula, and those variables change depending on the question and depending on the situation, right? So think of C here, think of this formula as the formula for figuring out the cost of something, okay? So C is the price or the cost, equals N, which is maybe the number of items you buy, and R, you can think of it as the price per item. So let's say you want to buy 5 tubes of lipstick. Okay, how much is it going to cost you? Well, N is 5, the number, and let's say each tube is 10 bucks. Okay, so what's C? 5 times 10, right? So, but then let's say tomorrow you decide that, well, you know that you've got, I don't know, 50 tubes of, no, you know that the lipstick cost you 50 bucks and you know that you bought 5, but you need to decide, you need to find out the price of each lipstick. Well, you can find that. And the way that you do that is you go back to your original formula. And then since you're looking for R, right, you want to get rid of N, because you always want to isolate whatever you're looking for. So in this case, you want to find out how much does each tube of lipstick cost me? That's R, right? The price. So you're going to get rid of N. And how do you do that? You divide both sides by N. So when you divide this side by N and you divide this side by N, N will cancel out N because N divided by N is 1, right? So N divided by N, because you're pretty much dividing the same variable into itself, right? So they cancel each other out. So N and N would cancel each other out, and you would be left with C over N equals R. And now you can plug in your values. You've got, you see on your receipt that you spent 50 bucks. And you also see in your purse that you've got 5 new tubes of lipstick. So how much did each one cost you? 50 divided by 5, 10. They were 10 bucks each, right? That's R, right? And let's say tomorrow you decide that you want to figure out how many tubes of lipstick you can buy. You saw an ad at Sephora, you know, I don't know. You want to figure out how many lipsticks you can buy for $50, okay? And you see that Sephora is having a sale, and all their lipsticks are $10, and you happen to have $50 in your purse, and you're like, oh, how many lipsticks can I buy? So what that means, we're interested in N, right? The number of lipsticks that you can buy. So you go to your original formula, and again, since we're looking for N, you're going to isolate N by dividing both sides by R. Okay, so you divide by R on this side, divide by R on this side. And so your new formula is C over R equals N. And now you can figure out how many lipsticks you can buy with the $50 in your purse. With Sephora's sale of $10 per lipstick, 50 divided by 10 is 5. So you can come home with 5 new lipsticks, okay? The same thing applies to any other formula that you want to change. What we just did here is called changing the subject, right? So here our subject was the cost. We wanted to know the cost. So this is the base formula. Here our subject is the price. We want to know the price, so we would need to change the subject to R by dividing both sides by N, right? Here we're interested in N, the number of lipsticks that you could buy. So you would change the subject to N by dividing both sides by R, okay? So a good rule of thumb to keep in mind is that whatever is the subject, whatever it is that you're looking for, you always want to isolate it. And so if you see that variable that you're looking for in a formula, you just simply isolate it by dividing both sides by the subject that you're not looking for, right? Or basically just think of it as isolating it, like getting rid of anything that you're not looking for next to what it is that you're looking for, okay? If it helps to think of it that way. So this is the formula for distance, and distance equals rate times time. So again, conceptually, if let's say you live 5 miles from the nearest Target, and you like to drive like a grandma 30 miles per hour, and it always takes you exactly 5 minutes to get to Target, okay? You can change this formula around to determine to find different variables based on what the question is asking you. So if the question is asking you, how long does it take Jaleesa to get to Target, right? That's a question about time. So what are you going to do? You're going to isolate T. And how do you do that? You divide both sides by R. Okay, so you're going to divide, if you divide the right-hand side by R will cancel out R and you'll be left with T. And then on your left-hand side, you'll have D equals R. D over R, I'm sorry. And that equals T, right? And so if you divide the distance, 5 miles from your house, by rate, you drive 30 miles per hour, that should give you approximately how long it takes you to get to Walmart, okay? Or Target. And then the same thing, if you want to find the rate, go back to your original formula. Rate meaning the speed, right? How fast were you driving when you got that ticket to Lisa? Okay. We can find that out. Divide both sides by T, okay? And then you can tell the judge, well, I wasn't going that fast. And I know I wasn't going that fast because I know how the distance from Target to my house. I know the rate, uh, uh, I mean, and I know what time I left home and what time I got to Target. So I can figure out how fast I was going. And then you would simply divide the distance by the time, and the judge would look at you and say, oh, Jaleesa, you're correct. You weren't going that fast. Case dismissed. You know, the cop was wrong. You don't, we're not, you don't owe a speeding ticket or something. I don't know. Okay. But I think you get the point. Like whatever, you can always just switch a formula, switch the variables in the formula around by changing the subject, and that involves canceling out whatever you don't need, rearranging it, putting it on the other side of your equation so that you can figure out the amount relative, or the amount that's relevant to the variable that you do need. Okay. Yeah, I think we just spent a lot of time covering that. So here's an example asking you to figure out how many miles you can travel if you drive at an average speed of 55 miles per hour for 3 hours. Okay. So you know that you're driving 55 miles per hour, and that the amount of time that you spent driving is 3 hours. So all you would need to do is substitute the values given to you in your question into the formula. So this is our D equals RT, right? So we know that distance equals rate times time. We know the rate, which is 55 miles per hour. Excuse me, we know the time, which is 3 hours. 55 times 3 is 165 miles. And that's the distance that you traveled, okay? A really good tip here is just to substitute all the values for variables back into your formula, and then make sure that you check your answer to see or to gauge whether or not it makes sense according to based on the information that you were given in the problem. Okay, and these are just more, so that's essentially the end of chapter 1 review. And then chapter 2, I'll just go over it really quickly because we just went over this a few days ago. We talked about decimals, a decimal system, and basically decimals are numbers that reflect amounts that are less than 1, okay? And they reflect those amounts by using place values. So if you think back to that number line that we talked about earlier today, where we saw 0.5, or we saw 1/4, then 0.5, then 3/4, then those are decimals that are, and all those numbers are less than 1, right? And those amounts are represented on that number line using their place values. And all those place values were less than 1. Okay. Usually when you see a decimal point placed after a whole number, everything that appears to the right of the decimal point indicates a portion of the whole number. And that's goes back to today's lesson. So you see why it's kind of important to recap, because now the stuff that we learned a few days ago is making more sense, right? Because today we talked about decimal equivalencies, right? And so this is telling you that every digit after a decimal point represents a portion of a whole number that you're dealing with. And so once you're in the zone beyond the decimal point, we're no longer talking about whole numbers, we're talking about a portion of that whole number. So if you see like 30.5, right, that 0.5 is telling you is a representation of a portion of that whole number. And the further you move to the right of the decimal, the smaller the portion becomes, right? So 30.5 compared to 30.55 compared to 30.555. You know, the further you move to the right of the decimal point, the smaller that portion becomes, meaning that 0.555 is less than 0.55, which is less than 0.5, okay? And we used, I used the examples of pies to illustrate that, so I'll go over that really quickly. The key thing to remember with decimal points is that a decimal point is used to separate a whole number from its decimal parts. So when you're rounding decimals, you want to follow the same rules that apply to rounding whole numbers. So remember our example where you were trying to figure out how much your boss needed to give you to get to Connecticut. You need to follow the same rules with rounding whole numbers as you need to follow the same rules for rounding decimals as you would with rounding whole numbers. So when you're dealing with a number, adding a 0 to the right of the last digit after the decimal point doesn't change the value of the number in question. So for example, let's say you bought something that cost you 50 bucks and you see 2 zeros on the right of that 50, you know that the zeros after the decimal point is constant, that there are no additional denominations that you would need to complete your payment. If you were giving if you were giving a $50 note, you don't need any additional denominations. You don't need 25 cents, for example. Okay. So that's essentially all this means, is that when there's a zero, adding a 0 to the end of a whole number doesn't change the whole number. And that's important because sometimes when you're dividing, you need to add a 0 so that you can have the correct number of place values. That applies also when you're subtracting or adding. Sometimes you need to add a 0 so that you can, when you're stacking your numbers, you have the same number of place values after each number in your column. So this is just letting you know that if you have, in the event that you have one number with less place values than the rest of the numbers in your group, for example, you can add a 0 to that number and it's not going to change its value. It's only going to act as a placeholder that helps you match the other that helps you match the number of place values in the other numbers in the group that you're working on. Okay. So you'll usually see a decimal point placed after a whole number, and everything that appears to the right of the decimal point indicates a portion of the whole number that you're dealing with, as we already discussed. And so once we're in the zone beyond the decimal point, we're no longer talking about a whole number. We're talking about a portion of that whole number. And again, the further you move to the right of the decimal, the smaller the portion becomes. So for example, the number that you see here, 2.375, that's shown below this number line, the 3 represents 3/10, okay? And the position of the 7 lets us know that we are 37/100ths away from 1, okay? And remember, the further that you move from the decimal point, the smaller the portion becomes. So I'll try to give you an example. Let's say that, and this is the example that I used in I'll use the same example. So let's say that you've bought a pie and that you decided to cut your pie into 10 slices, okay? And then let's say 3 of your friends took a slice each, right? You would say that 3/10 of your pie was taken by your friends, okay? But let's say that the next day you decide to buy another pie the same size, you know, because it was so yummy, and then you let's say that evening you have 100 dinner guests, okay? And so you decide to slice your pie into 100 into 100 thin slices so that each of your guests can have a taste, right? At the end of the evening, let's say 37 of your guests took a slice, you would say the 37 hundredths of your pie is gone. So the same concept would apply to the 5 here. Let's say that you decide to buy another pie, okay? And this time around, you slice that pie into 1,000 pieces, and then 375 people took a slice, right? You would say that 375 thousandths, right, of your pie is gone, right? And so that's why this number 2.375 is more formally, it's read as 2 and 375 thousandths. Okay. And so again, just in terms of moving away from the decimal point, the more with each place value away from the decimal point, the smaller the number becomes. And if it helps, you can visualize that pie, right? Like, so when we just sliced the pie 10 ways, right? Those slices were much bigger, right? And then we had to slice them 100 ways, and then they became smaller, right? And then we had to slice them 1,000 ways, and they became infinitely small. Like, so the more you move away from the decimal point, the smaller the number, the value of that decimal becomes. Okay. Excuse me. So normally you would hear these tenths and hundredths and thousandths and 10 thousandths places being referred to when you're talking about rounding decimal points. So for example, if on the test that you're told to round to the thousandths position, and let's say your calculator is showing something like this. This is the display on your calculator, 2.375242, on and on and on, right? And you're told to round that number to the thousandth position, or you're told to round your answer, right, to the thousandth position. Well, you're going to stop at 2.375, okay? And so that's essentially the point that you need to remember here, is that you'll hear tenths, thousandths, hundredths, thousands when a reference is being made to decimal points, and the goal is for you to round to a certain position on the number line, or to a certain place, to a certain number of decimal places. Okay. So informally, or more commonly, you would read this number as 2.375. And even the informal way of reading this number lets you know that each digit plays a unique role. So we don't read this as 2.375, right? You would sound out each digit, 3, 7, and 5, to reflect their unique and individual positions on the number line. Okay, and then here's a tip that's kind of similar to placing a 0 after the decimal point that we had discussed earlier. If you place a 0 before the decimal point, the value essentially stays the same. So 0.75 is the same as 0.75. in the event that you need to place a 0 here as a placeholder, for example, you now know that that doesn't affect the value of the number, excuse me, of the decimal number. Let's see. I think that we can. Do you want to discuss rounding? Is that something that? Well, okay, I'll go over this because earlier I try to make the point that when you're rounding, you follow the same rules that you would follow with whole numbers. So remember our Connecticut example? Well, that was a whole number, right? We were rounding, I think it was 2,451, and we rounded it to 2,500. Okay, in this, excuse me, in this example, we're being told that your calculator display reads 3.62835, and you're told to round to the hundreds place, right? And so you start by looking at the digit to, this is your hundredths place right here too. So you would look at the digit to the right of that, which is 8. And since 8 is greater than 5, remember the rule is 5 or greater than 5. Since 8 is greater than 5, we're going to round up, right? So we're going to round the 2 up by 1, and our approximation of this number 3.62835, the 6 point getting tired 3.62835 rounded to the nearest hundredth is 3.63. Okay, and that's this 3.63 is an approximation of this number rounded to the nearest hundredth place. Okay. So here we're being told that Matt ran the same 400-meter race in 4.58 seconds as Alonso, who ran his race in 45.66 seconds. And then you're being asked to determine which runner had the fastest time. Okay, so the first thing you want to do here is stack your numbers into a column so that you can align each decimal point. And then next you want to add a 0 to the end of 4.8. So this goes back to what we were discussing earlier, that when you add a 0 to the end of a sequence in a decimal number, excuse me, it doesn't change the value of the number, but it does help you in case the numbers that you're comparing have more decimal places than the number in question, which in this case is 45.8. So we add a 0 to the end of 45.8. Now have 45.80. And then you can just compare them, the decimal parts, as though they were whole numbers. And you know that 80 is greater than 66, right? So you decide that Alonso's time was the fastest because he ran 45.8. And yeah, that's essentially your answer. And so this is a good example of the concept that we were talking about earlier. And sometimes you need to add a 0 to the end of a decimal to help you with your comparison or to serve as a placeholder. Yeah. So here we're being asked to order 0.85, 1.8, 0.8, and 0.819 in order from greatest to least, right? So the first step, again, excuse me, is to stack your numbers in a column so that you can align the decimal places. And then you want to make sure that all your numbers have an equal number of decimal places after the decimal point. So we know that the highest number of decimal places here is 3 with 0.819. And then we have two numbers that only have one decimal place and one number that only has two. So we need to add zeros to these three numbers, these first three numbers, so that they match the number of decimal places here, right? And then once you've done that, you can start you can start working on comparing your digits from left to right. And so since 1.8 has a whole number, it's the only decimal number that has a whole number, the others have zero, we automatically know that it's our largest, right? Then you start looking at the rest of the numbers, the remaining three numbers, 0.85, 0.800, and 0.819, all start with, excuse me, all have 8 in the 10ths column. So then you would move over to the hundredths column. And we see that 0.850 has a 5 in the hundredths column. And that means that it's the next highest number, right? Followed by 0.819, which has a 1 in the hundredths column, right? And so then you would order your numbers 1.8, 0.85, 0.819, and then 0.8, okay? And again, you can think of this, you can cross out the, what do you call it? The first two numbers, okay? And then compare them as whole numbers. And you can see that 50 is greater than 19, which is greater than 0, right? So that's another way that you could order that or determine the order. So since 50 is greater than 19, and which is also greater, and it's also greater than 0, we know that our next number in this order is 0.85, then 0.819, since it has 19, followed by 0.8, okay? So yeah, in terms of operations, the key takeaway is just making sure that you you stack up your decimals so that they have the same number of decimal points in the columns in your stack. And then you want to make sure that the decimal point in your answer matches the same location as the decimal point in the values that you're working with. Okay, so adding decimals is the same as adding whole numbers. Again, the trick is to make sure that you've lined up your columns correctly so that each of your numbers has the same number of decimal places after the decimal point. And then you also want to make sure that the decimal point in your answer is perfectly aligned with the decimal point in the values of in the question, in the values of the question. And that's just what we're seeing here. So here we have one number that has 3 digits after the decimal point, one number that only has 1, and one decimal number that only has 2. So you want to stack your numbers into a column and then make sure that you have aligned your decimal points. And then for those numbers that have a different number of decimal places after the decimal point, you want to add zeros. So for 0.5, we'll add 2 zeros so that it now matches the number of decimal places after 2.638. We'll add 1 zero to 0.367 so that it also matches. And then you just proceed with your addition as you would normally with the whole number, just making sure that your answer reflects the same position as the decimal point. Okay. And you know how to add, right? So I'm not going to bore you with this part. Same rule with subtraction. You want to make sure that if you have a value that has okay, for example, this value has only one decimal place, whilst this one has three. So you want to make sure that you add the appropriate number of zeros that would catch you up to the number of decimal places here, 14.512. So you would add 2 zeros after 8.7, and now you're even in terms of the number of decimal places after the decimal point. Start by putting down your decimal point where your answer is going to go, and then just continue with your subtraction as normal. Okay. This tip essentially is just telling you that sometimes you can round the numbers in your problem so that you kind of and then gauge your have a number in your head in terms of where your answer should be, so that when you're done with your calculations, you can gauge the number that you got, or the answer that you found, with the number that you began with in your head, to see if you're still in the same ballpark. So for example, if you're asked to add 7.2 plus 1.4, your final answer shouldn't be 59.38, for example. So you would try to mentally round the numbers to the nearest whole number, and then proceed with the required operation, which in this case is addition. And your result should be close to the approximation that you had. So for example, if you could mentally round 7.2 to 7, since the number after the decimal place here, 2, is less than 5. Remember, the rule is if the number to the right of the place that you're interested in is 5 or greater, we're going to round up. And if it's 5, and if it's less than 5, we're not gonna change the number, right? Or in this case, we would round down. So since this 0.2 here, 2 is less than 5, so we'll round down 7.2 to 7. And since 1 is less than, since 4 is less than 5, we'll round down 1.4 to 1. So we know that 7 plus 1 is 8. And so in our head, we know that our number should be close to, or should at the very least be less than 10. So when we do our final calculation, and we get the exact answer, 7.2 plus 1.4 is 8.6. That's less than 10, right? And so we know when we compare 8.6 to our approximation of 8, we know that we're in the same ballpark, okay? And we don't have 56.8, for example, right? So we know that our answer is in the ballpark of our approximation. So we're feeling safe with the answer that we found. Essentially, that's what this tip is telling you here. And I'll go over this a little bit. I'll go over the subtraction, and then I think we can and the lesson because everything else you already know, or I think at least this is the point where you joined the course last time. Okay, so here we're being asked to subtract 9 from 3.604. So the first thing you want to do is you want to put zeros. You want to put zeros after the 9 so that you match up the number of decimal places, because 9 is essentially the same as 9.0000, right? 000 into eternity. Like, we can have our little bar up here if we like, but there's no need for that, right? So 9.000 minus 3.604. Now we're ready for our subtraction, okay? So in this case, since we have 0 in the thousands, we have 0 in the hundredths, and we also have 0 in the tenths. That means we need to borrow from the tens column in the whole number section, right? So we borrow 1 from 9, that leaves us with 8. And then, so you put a line through 9, write down 8. But before we get back to the thousands column, we need to regroup each step of the way, right? So you can think of it as paying a toll before you pass over the bridge, right? Each decimal place is literally saying, hey, Jaleesa, before I let you cross over, you need to give me a 1, right? So we add a 1 to the tenths column, cross that out because we need to give a 1 to the hundredths place. So we cross that out, we write down 9, give our 1 to the hundredths place. We're going to cross that out, write down 9, and now we're finally over in our thousands place, right? And then we can proceed with our subtraction. 10 minus 4 is 6. 9 minus 0 is 9. 9 minus 6 is 3. And 8 minus 3 is 5. Okay. And I felt I wanted to go over that because if you find yourself in this scenario, know that before you get back to whatever place you were, so let's say you were in the 10,000s place, for example, you would have to leave a 1 with the thousands place before you can cross over. Okay, so if you find yourself in a place where you have several zeros, each time you cross over, you have to leave a 1. Okay. Yeah, okay, so this is just telling you that when it comes to multiplying and dividing, you want to apply the rules that we learned for multiplying whole numbers, but for multiplying and dividing decimal places, you don't have to align your decimal places as we did with addition and subtraction. You wait until you've completed your multiplication or your division. And then place your decimal point based on the number of decimal places that appear in the numbers in the problem. Okay. Jaleesa, are you still there?
Yeah, I'm still here.
Okay. So do you want me to go over this?
No, I get this too.
You get it? Okay.
Mm.
All right. So that's essentially it then. We have covered chapter 1 and we've covered chapter 2, and you can see that this is picking up pace, right? It's adding up. So don't leave the work to a later date, because it just means that you have to play catch up, and then you're making it more difficult for yourself to absorb the information, like it's good for you to go at the pace of the lessons. That way you're staying on task, And then you also give it, because that's why you see the book kind of paces, and it'll, after each lesson, it'll give you a set of questions and then moves on to the new information. It paces like that so that you can give yourself time to work through the concepts that were covered in that lesson, and gain some kind of foundational understanding before you move on to the next thing. So basically, I'm trying to say, don't leave the practice, don't leave too much time in between working on the practice problems so that you can keep up, because the lessons are only picking up pace, and each lesson for each chapter, each lesson has a bunch of practice problems, right? So give yourself time to work on them, so that, especially if you have questions, you can ask, and we can work through them together, so that you're not falling behind, and so you're staying on task in terms of how the lessons are progressing. Okay, so before the next class, which is on Thursday, we only have a day. I'm not sure if you will have time, but if you do, try to work or at least catch up on the problems from the lesson. Or at the very least, by this weekend, make it a point to have covered the practice exercises from chapter 1 and chapter 2. Because on Thursday, we're moving on to chapter 3. Okay. Yeah, if you don't have any questions and you're okay, we can go ahead and end tonight's lesson. And then on Thursday, we'll pick up on chapter 3.